Now we're looking at rational functions. And so to graph these, horizontal vertical asymptotes are going to make life a lot easier. So horizontal asymptote, you compare the variables. Um, if they're the same, you take the ratio of the coefficients. If the one on top is smaller than the one on bottom, it automatically is going to be y equals 0. And so basically, if there is no variable there, what's going on is its exponent is basically like 0. Okay. Um, and so that's what happens there. So the power on top is smaller, so it defaults to that. Now for vertical asymptote, you take the denominator and set that equal to 0 and solve. So you get x equals -4. So we'll go ahead and plot these. So y equals 0. That's just actually just the x-axis basically. But I'll go ahead and put it right there. And then x equals -4. That's going to be right here. Okay. And then now we'll go ahead and find some points. And really, you just need to find 2 points. That's it. So we'll go ahead. We'll start with f of -5. So f of -5. That'll give us 3 over -5 plus 4. That'll give us 3 over -1, which is -3. So I'm right there. There's my point. And so when I graph this, just kind of go towards the asymptote here and curve up towards the other asymptote there. If you want to find additional points, you can, but the asymptotes really make your life a lot easier. So now you need to find one on the other side. It's probably going to be diagonal, but it is possible that they could be side by side. So we want to go ahead and plug in. It looks like -3 would be a good one. So let's see, f of -3, we'll get 3 over -3 plus 4. So this time we end up with 3 over 1, which is 3. So we'll be right up here. And then once again, just kind of use those asymptotes as a guidance for your graph. And there you go. That's it. That's all you got to do. Now this one, is pretty straightforward, not too bad. Next one shouldn't be too bad either. But eventually we'll get multiple vertical asymptotes. And you just have to find a couple additional points, but it's shouldn't be too bad. Okay, so here's our next one. And it really shouldn't give us too much trouble. Very similar to the one we just got done doing. The difference here is that they do have the same power. So what you'll do is you'll take the ratio of the coefficients. So 3 divided by 1 is 3. So that's going to be your horizontal asymptote. Vertical asymptote, you take the denominator and set that equal to 0. And so you get x equals +3. So it's a coincidence. They happen to both be the same, but it's a coincidence. So let's see, here's our y-intercept, our x-intercept, so x equals 3. I want y equals 3. And so now we just need to test some points. 0 is an easy one, right? So 0 would actually be a fairly easy one to plug in and see what happens. So let's see, f of 0, 3 times 0 minus 2 over 0 minus 3. So we end up with -2 over -3, which is +2/3. So at 0, when x is 0, you're 2/3 right there, 2/3. Okay, and we can go ahead and draw that. So as I go from left to right, I'm going to start curving it towards the asymptote. And as I go to the left, I'm going to curve it up and towards the asymptote. And it's not perfect, but it's in the right position, and I'm sure it's fairly accurate. If you were to try to find some additional points, that's going to be pretty good. Okay. Now let's try, I guess, f of 4. Let's see, f of 4, 3 times 4, take away 2, all over 4 minus 3. So we get 12, take away 2 over 1. 10 over 1 is 10. We end up kind of high up here at 10, and that's fine, not a big deal. So then when you draw your graph, just kind of curve it down going towards the asymptote like so, and that should be fine right there. So the first two we looked at, we had a single vertical asymptote. Now we're going to look at a couple that have two. And on the exam, you can pretty much expect one of each. Okay, so one like this page, and then you can expect one that's going to look more like what you see here. Okay, so on this first one, if you compare the power, the exponents from the numerator and denominator, you'll see you've got 1 on top and 2 on bottom, so that defaults to y equals 0. Then if you take the denominator, x squared minus 4, set it equal to 0 and solve, factors into x plus 2, x minus 2. So you've got two vertical asymptotes, x equals negative 2 and x equals positive 2. And so we'll go ahead and put those on our graph. So y equals 0, that's just basically the x-axis. And then we have negative 2 and positive 2. All right, so in this case, we're going to have to actually test 5 points, because in the middle, you need to get 3 points to kind of get an idea of the shape. Because there's a couple different shapes that could come out of the middle part. On the edges, you just need 1 of each. So altogether, we're going to get 5. So let's see, we'll start with f of negative 3. So if I plug in f of negative 3, let's see, 2 times negative 3 over negative 3 squared minus 4. So I get, let's see, a negative 6 over 9 minus 4. So I get negative 6 over 5. So like negative 1.2. Right there. We can go ahead and draw this. So it's going to curve going up, curve going down like that. And that's fine. You can do that part right there. Now in the middle, we need to find 3 points. So we'll do f, we'll start with negative 1 and then count down to 0 and then positive 1. So f of negative 1, let's see, we're going to have 2 times negative 1 over negative 1 squared minus 4. So we get negative 2 over 1 minus 4. So we get negative 2 over negative 3, which then turns to positive 2/3. So we're about right there. Okay. F of 0 should be pretty simple because 2 times 0 over 0 squared minus 4. So you end up with 0 over negative 4, which is just going to be a 0. And now we'll do f of positive 1. Okay, so let's see, that's going to be 2 times 1 over 1 squared, take away 4. We end up with 2 over 1, take away 4. So then it's 2 over negative 3. So basically negative 2/3. So it's going to be down here. So what that tells us is that the shape in the middle is going to kind of take on a cubic shape where it kind of bends in the middle, kind of curves down like a parabola, and then curves kind of like a parabola opening down, kind of like that. And there you go, that's what you got in the middle. Okay, for the last one, we need to figure out f of positive 3. And I'm going to go ahead and erase this so I can have room to put it right down there. So let's see. F of positive 3, so we get 2 times 3 over 3 squared minus 4. So then we get 6 over 9 minus 4, we get 6 over 5, which is 1.2. A little bit higher. There we go, 1.2, about right there. And then once again, very similar to the other, well, it's really pretty much the same as just the reflection from the other side right there. All right, so we got one more of these to go. Should be pretty similar to the process we just saw there. Okay, so one difference on this one is it has a horizontal asymptote of 1 over 1, which would be a 1, because the power here is a 2, so they actually are the same, so you take the ratio. Denominator is kind of similar to where you're going to factor it and get two vertical asymptotes. So one of them is at -3, and then you have another one at +3. So y equals 1. There's our horizontal asymptote. And then we have two vertical asymptotes, one at -3 and one at +3. Now, what's going to make this problem actually a lot easier is if you recognize that it's an even function. And if you notice, all the exponents are even. So basically, whether you plug in a positive value or a negative, they're going to result the same. So like, if you plug in 2, it'll be the same for f of -2. 3, same thing for f of, well, you don't want to plug in 3, but like, so here we want to plug in f of -4, but what will happen is you'll get the same result of f of +4. So it's going to cut down on how many points we have to plug in, make things just a little bit easier for us. Okay, so we'll go ahead and start with that 4. So let's see, you get 4 squared over 4 squared, take away 9. So we get 16 over 16, take off 9. So we get 16 over 7, which is a little bit more than 2, like 2.3 something like that. So let's see, we're going to be 2.3 about or so, right? And same thing for, well, I plotted it first for -4. So for -4, I'm up here at 2.3 about. And then over here at +4, same deal. And you could just use your calculator if you needed to kind of get an idea of where that's at. And so then we'll go ahead and curve going up towards the asymptote, down towards this asymptote. And we'll do the same thing here. Okay? And then for finding some points in the middle, I don't know, I guess I'll go with -2. I could do -1 if I want. Doesn't really matter, but it's going to give me the same result for f of +2. So we're going to get 2 out of the way for the price of 1. So let's see, 2 squared over 2 squared minus 9. So we end up with 4 over 4 minus 9, which is going to be 4 over -5. Okay, so that's like -0.8. So we're going to have -0.8 for -2 and for +2. And then we'll go ahead and plug in f of 0. That would probably be a pretty easy one to find. So 0 squared minus 9. So end up with 0 over -9, which is just 0. So this is kind of going to be parabola shaped here in the middle, but it's also going to be very flat at the bottom. So it's that curve where it first starts out really kind of is pretty flat right there. I mean, you want to curve it, but it's very, you can tell right there. It takes some time to start going like this. But as you get closer to the asymptote, it's going to take off down to -infinity on both sides. And so that's what's taking place there. All right, so that's rational functions.